Alright, in this video I'm going to do number 64, which is the mobile problem. And it says that you have object B has a mass of 0.735 kilograms. Determine the masses of the other objects. Alright, I'm going to redraw this so that it's a little bit bigger and I can use it. And I'm going to put stuff in meters just because we should do stuff in meters. And we can figure out this problem. Alright, so we have an object hanging here, which is object D, and then object C is here, and then there is a string, and this is 0.175 meters, and this is 0.05 meters, and then that string attaches over here, and dangling on this side I've got the only mass that I know, which is 0.735 kilograms, okay? And then there's a string hanging here, which has 0.05 meters, and then 0.15 meters, and then the last one is like this. Oops, it should look like this, sorry. And then there's a string pulling here. Let me move that over a little bit. So there's a string pulling like right here, and over here I have thing A dangling, and I want to know its mass, and it's 0.3 meters away from this, and this is 0.075 meters away. Okay, so I've got it all drawn out so I can see it here. Now, really what I want to do is I kind of want to start thinking about what's going on in this problem, and then how am I going to go about solving it. So I'm going to stop and I'm going to start and work from the bottom down, or from the bottom all the way up, okay? So I kind of want to look here and I see, all right, well, there is this object here and here. So we've got force D, okay, force times D on thing D has to be equal to force times D of thing C. Okay, that's one thing I can say. And then if I look here, I know that force, and remember this is thing B, force on thing B, let me see, how am I doing this? Force times D of thing B is equal to the force of both C and D times D. Okay, hopefully that's not too confusing. Really all it says is that these two things are balancing out, and then this whole thing is balancing out this whole thing. Okay, so what I'm going to do is I'm going to use the information that I have use these two problems to help simultaneously solve for another one. Okay, so here I've got FD and FDC. Let's sub in what I have there. So I know that the mass of thing D times gravity times 0.175, so this times this guy's weight, has to be equal to mass of thing C times gravity times 0.05, and my gravity cancels out. Okay, what this allows me to do is solve for something in terms of either MD or MC. Okay, and in this case I'm going to solve let's just solve for MC. So I know that the mass of thing C is actually equal to the mass of thing D, and then I'm going to divide by 0.05 on both sides, so divide by 0.05, and actually get times 3.5. Or if I want to write it a little bit neater, I would say the mass of thing C is 3.5 times the mass of thing D. Okay, so now I'm going to go to this problem, right? Because I have B, and now I have eliminated another variable, okay? So I'm going to say the mass of thing B times gravity times D, so that's this part of it, is equal to the mass of thing D plus the mass of thing C, all times G, times the second D, right? So D, another D. Okay, so really all we're saying is, and I'll come back down here to this, is we're saying this whole thing together times 0.15 is equal to this whole thing together times 0.05. Okay, so the mass of thing B, our gravity, remember, cancels. So this torque is equal to this torque, okay? And we've used this equation to be able to eliminate C, right? So I can plug this in for mass thing C. So I get MBD equals MD plus 3.5 MD all times the distance. Okay? Now I only have one variable. The mass of thing B is 0.735 times distance. If we look back up here, it's 0.05. Okay? Times 0.05 is equal to 4.5 MD, so 1 MD plus 3.5 MD, all times, look back up here, 0.15. 0.15. Okay, so now just solve for MD. I'll take, you can't see that, okay, so 0.735 times 0.05 divided by 0.15 divided by 4.5. And I get the mass of D is equal to 0.05 kilograms. Okay, so if I go back up here, I can label this at 0.05, and we'll keep it 0.054 kilograms, right? Now, if I have D up here, I can find MC. So I just need to multiply MD by 3.5, and it'll give me MC. So times 3.5 gives me 0.19. Okay? Now the last thing that I need to do is figure out A. Alright, so really all I need is the mass of all of this times 0.75 is equal to the mass of A times 0.3. Okay? So, and remember, we're ignoring the mass of all the strings and the bars and everything, which makes it way easier. Okay? So we're going to say 0.075, which is the distance. And remember, my gravity is going to cancel out, so I can really just add up these three masses. So 0.19 plus 0.054 plus 0.735 gives me 0.979 for the mass. Okay. It's got to be equal to the mass of thing A times 0.3. Okay, so 0.979 times 0.075 equals all divided by 0.3, and I get that this guy is 0.244 kilograms, or mass A equals 0.244. Okay, so not too hard. Just remember, it's an important lesson to, understand this idea of being able to solve for something in terms of something else, and use it to eliminate variables.